On guys, let's look at this problem right here. Here we have a prism and light ray is hitting that prism horizontally, and the first surface, the hitting surface of the prism is straight vertical, so the normal also going to be a horizontal. So the angle theta 1 is going to be 0 degree, right? And the question here is, after this light ray leave the prism, it's going to hit this mirror. Here we have a mirror and a prism, and when it hits the mirror, what's going to be the angle of reflection below the horizontal? That's what we are trying to find. Now before we do that, let's go ahead and find what's going to be the angle of refraction right here. To find that one, we can use the Snell's law. Snell's law says n1 sine theta 1 is equal to n2 sine theta 2, and here we know that n1 is equal to 1 because this is AR, and n2 is going to be 1.56, and n1 sin theta 1, n2 sin theta 2. Here what we are trying to find is theta 2, what's the angle of refraction inside. To find that one, we have to rearrange this equation. Theta 2 is going to be equal to, first let's put sin theta 2. Sin theta 2 is going to be equal to, sin theta is going to be equal to n1 sin theta 1 divided by n2. Okay, since we are trying to find theta 2, we can bring the sine also to the other side. So this is going to be sine inverse n1 sine theta 1 divided by n2. Now let's go ahead and plug the values. Sine inverse n1 is going to be the index of refraction of the AR, that's 1, and the theta 1 is the incident angle, that is 0 degree right here. So this is going to be sine 0, and then divided by the index of refraction of the glass, the prism glass, that is 1.56, and we know that sine 0 is 0, so that's going to make the whole thing 0. So sine inverse 0 also 0, so the theta 2 is going to be 0 degree. So it means this angle of reflection also going to be 0 to the normal, so it's going to be just a straight line. Now we have to know what's going to be the angle of refraction after it hitting this surface. But this surface is not vertical like this, right? This is 0 because it's vertical, but this surface is a little bit inclined. And here if I draw a normal like this, let's draw a normal. Okay, so let's if we extend a normal, and this is horizontal, and this is a normal line, and here we have an apex angle that's 10 degree. So that should from this one we know that this should also 10 degree, right? Because this is normal and this is a horizontal. So since the apex angle is 10 degree, this one also must be 10 degree. Now we know that angle of incident, that is 10 degree. Again, we can go ahead and use the Snell's law to find out angle of refraction. To find this one, we are going to use n3. Let's call this angle n3. n3 is equal to 10 degree. Okay, n3 is equal to 10 degree. So not n3, theta 3. Theta 3 is equal to 10 degree, and n3 is same surface as n2 because we are still inside of this prism. So n3 is going to be also 1.56. n3 sine theta 3 is going to be equal to n4 sine theta 4. Here we are trying to find theta 4, what is the angle of refraction. To find this one, we have to rearrange this equation. Sine theta 4 is going to be equal to n3 sine theta 3 divided by n4, and we are trying to find theta 4 alone, so we can move this sine to the other side. So that's going to make this one theta 4 is equal to sine inverse n3 sine theta 3 divided by n4, and n3 is the index of refraction of this glass, prism glass, that's 1.56. So sine inverse 1.56, and the theta 3 is angle of incident inside, that is the angle that is making with the normal. So this light ray is making 10 degree with the normal. This is our normal line, and this is making 10 degree with the normal, so this is going to be sine 10 degree. And in the below n4 is representing the index of refraction of the refracted side. Refracted side is outside, so it's going to be AR. Index of refraction of the AR is 1, so this is going to be just 1. And sine inverse of this one, if you calculate this one, you will get 15.7 degree. Okay, so this is going to make the refracted angle is going to make 15.7 degree with the normal. Okay, and this is going to make 15.7 degree with the normal, 15.7 degree with the normal. But if we extend these two lines, this line and this line, okay, not this line, this horizontal. Okay, let's extend this one. So here we have 10 degree, and this one is making with this one, right? This horizontal. So let's say this is horizontal, and this is little bit inclined. Okay, this blue ray is little bit inclined, and this is horizontal. I'm extending the horizontal. This should be little bit straight right here. Now to illustrate this one better, I should draw a straight line. Okay, let's go ahead and draw a straight line, straight horizontal. I should draw this one again. Okay, straight horizontal. Okay, then it's going hitting this one straightly, and then it is refracting like this. Okay, and the refracted light is making 15.7 degree with the normal. This is our normal, and if we extend this horizontal line like this, and the normal is like this, and this is making 10 degree, right? This one is making 10 degree with the normal. This horizontal is making 10 degree with the normal, and outside also that's going to be the same thing. This normal and this horizontal should be also 10 degree, right? So if this is 10 degree, this one must be 5.7 degree, because we found out that this theta 4 from here to here is 15.4. From here to here it's 15.4, and we found out this is 10, so this one must be 5.7 degree. Okay, this is 5.7 degree, and after it hit the this mirror, we have to know what is the angle of incidence right here. To find this one, what we can do is we can draw the normal to this mirror. Normal to the mirror is going to be 90 degree with the mirror, so that's going to be like this. And this normal and the normal with this prism also same, right? This is parallel. These two are parallel to each other, and from this one we know that this is making a z-zip. So from z-zip we know that if we have parallel lines and if it makes z-zip, this angle is equal to this angle. So the total angle here is 15.7, so this one must be also 15.7. Okay, and also if you draw a horizontal line, that is making, again this is making parallel to this one. This horizontal is parallel to this horizontal, and it's making a z-zip, and from that one we know that this angle must be equal to this angle, and we found out this angle is 5.7, so this one must be also 5.7. So if this is 5.7, this one must be 10 degree, because the total angle is 15.7, this is 5.7, so this is 10 degree. So this is our angle of incidence, because the normal with the ray, that is angle of incidence. So the angle of reflection and the angle of incidence is same in the mirror. So when we reflect in the mirror, when the light ray reflect, the angle that's going to make with the mirror is going to make with the normal is going to be 15.7 degree. But the question here is asking what is the angle of reflection below the horizontal. So this is our horizontal, and below the horizontal this is 10 degree. 10 plus 15.7, the total angle below that horizontal is going to be 25.7. So theta r is reflection, that is 15.7. Angle below the horizontal, let's say BH, below the horizontal, that's going to be 15.7, and from the horizontal to here, that's 10 plus 10, that's going to make this one 25.7 degree below the horizontal, and that's going to be the final answer. I hope this helps. Thanks for watching.